All right, so we've got a person running here. Let's say this is a stunt person, right, in a movie, and we've got a 5-meter drop on the building. Like the movie where they like run and jump off the edge of the building. So we're just going to run off the edge of the building. So we're going to turn this person into a horizontal projectile. The buildings are 3.5 meters apart. There's a 5-meter drop, and they're running at 3 meters per second, right? And we just want to know, are they going to make it, right? Are they going to land safely on the roof? Are they going to splat into the side or whatever, right? So when we have these kinds of things, we want to be careful what we set equal to each other, right? We don't want to necessarily say, we want to say, well, what's going to dictate how long it's going to be in the air? How far apart the buildings are doesn't really dictate how long they're going to be in the air, as well as the 5 meters drop, right? I think it's there's a couple of ways we could go about solving this one, but I think the easiest way to solve this is say, well, how long is it going to take them to drop this 5 meters? And then we can plug that back into our speed and say, well, at that time, have we gone far enough, or are we not quite far enough yet, or whatever, right? So, so if we use the y here to figure out how long is it going to take for us to drop 5 meters, so we say, well, y equals 1/2 at squared, right? So if we do a -5 meters equals 1/2 of -10, just using 10 for a thing, right? Make life easy, is t squared. So 5 equals 1/2 of -10, so that's 5. So -5 divided by -5, well, let's go ahead and show that step. Right, so -5 equals -5t squared. So divide both sides by -5 meters per second squared. And that's going to give us 1. So t squared equals 1 second squared. So square root both sides, and square root of 1 is 1. So the time is 1 second, right? That was a happy accident. When I wrote my problem, it came out to exactly 1 second, right? So it's getting 1 second, he's going to have dropped to this spot. Is he here or here or wherever? How far has he gone in that 1 second would be the way we'd go about doing that now, right? Always a good idea to pause me and work ahead any of those times, right? So now we say, well, now what can I do? Well, now I can use my x stuff. We know he's going 3 meters per second. So x equals 3.0 meters per second times 1 second. And so he goes 3 meters. Well, 3 meters is not 3.5 meters, so he's going to hit the side of the building, right? So he's not going to make it. Well, that's really sad, right? Well, how about instead, what if he did jump, right? Let's say, what if he did jump? Let's say he jumps, let's say he goes ahead, and we'll keep the 3 meters per second, but now he's going to jump at a 30-degree angle, right? Going to jump at a 30-degree angle. Now I'm going to completely change my approach to the problem. Now I'm going to say, well, how long is it going to take him to go this 3.5 meters? Because he's going to come up and then back down some. And so I'm going to want to say, well, did he drop the full 5 meters or what, right? So I'm going to use the 3.5 meters to determine the time now, and then see how far he drops during that time, because we have different information now, right? So this is more like a field goal kind of problem. So I'm going to resolve the vector. So let's solve for our Vx is no longer 3 meters per second. Now it's 3 meters per second times cosine of 30 degrees, right? Because if you're running and then you take and jump up, you're going to transfer some of your velocity upwards. So we're just saying he runs and now he jumps at 30 meters or at 30 degrees. So 3 cosine of 30, his velocity is now 2.5 meters per second. 2.6 actually meters per second. Let's not rob him. I haven't actually worked this problem. I don't know if he's going to make it or not. So we don't want to rob him of a little bit of speed there. So 2.6 meters per second. That is x velocities in projectile problems are constant, right? So we can say, well, x equals our velocity in the x times time. We don't have any acceleration in the x. So we can say 3.5 meters divided by 2.6 meters per second equals our time. So 3.5 divided by 2.6 is going to give us 1.34 seconds. Like the nice person in me, I know you don't believe me, but I'm actually nice. I wanted to get rid of the 0.404 there. Like, well, maybe that'll help him a little bit, right? A little less time in the air is a little less time to drop, right? So it's going to be 1.34 seconds. We know he's going to come up and be coming back down. I can't use like, well, what's his max height? Because that's not it. He's not going to come back down to the same place here. But I know he's going to be in the air for 1.34 seconds. At that time, he's either going to land on the roof or he's going to splat into the side, right? One of those two things. Well, he'll be right at the edge here, I guess, so he wouldn't. But is he still high enough? Is he still above this roof over here? Is really what we're solving for there. So then we would say, well, y equals VIY times t plus 1/2 AT squared. Again, not a bad idea to pause it and work ahead of me there. My velocity in the y direction I didn't already solve for. That was sloppy. I should have done that when I was resolving my vector. But that would be 3.0 sine of 30 degrees, which is just half, so that's 1.5. So 1.5 meters per second times the 1.34 seconds plus a negative 1/2 times 10, well, I guess the negative's here, negative 10 meters per second squared times 1.34 seconds squared. So we go 1.5 times 1.34. So his body tried to go up 2.01 meters, but during that time, gravity's dragging it down, right? This is the part with no gravity affected, right? If you had done this out in outer space kind of thing. So negative 5 times 1.34 squared gives a minus 8.98 meters down. Uh-oh, this is not looking good. Plus 2.01 is negative 6.97 meters would be our delta y. So in that time, he would have dropped 2 meters too far, right? So he jumped up and then came, right? And so he ended up landing 2 meters, or he was down 2 meters on the side of the building. Although if he's 2 meters tall, maybe he caught it with his fingers, right? Maybe he's 2 meters would be pretty tall. That's what, 6'8" or something like that, right? Anyway, hope that helps on a couple projectile problems.